Alright, in this video we're going to learn how to use logarithms to solve some real-world problems. Okay? Logarithms are what you need when you need to find the exponent, if that's the thing that you're looking for. So, we talked about these types of problems before. When we're talking about compound interest, as soon as I see compound interest and quarterly, then this is the formula that we're looking at. So it's like y is equal to, and P stands for the initial amount, the principal, and it's going to be 1 plus, and then it's going to be the rate, and then we have this n down here that represented the how many times a year we're compounding our interest or collecting interest, and then that's going to be to the nt power. So as soon as I see those words at a glance, compound interest, quarterly, boom, I know this is the formula that I'm going to use. Okay? As opposed to, I'm glancing down at number 5 for contrast. When I see continuously, there's a different formula that we use for that. Do you remember what that is? PERT. That's that PERT formula. Okay? It's still the same P for principal, but then it's E to the RT power. Okay, so that's what we're dealing with. All right, so let's substitute what we know into this equation and see what we have. So we invest $250. Okay, so where is that going to go in the equation?
Right side.
That's the P. Okay, so I got $250, and then I had 1 plus. Now I need the rate. What do I put up here? All right, that's 7%. That's 0.07 as a decimal, so 0.07. Down here was that n. All right, quarterly. What's n when it's quarterly?
4.
N is 4 when it's quarterly, so I'll put a 4 here. Now here was nt, so I'm going to put 4 again. How many years do we have? We don't know that. That's what we're supposed to find. How long? Okay, so we're going to have to leave that as a variable. That means we must know the other number. Okay, we must know the answer. What's the answer? Right, we want to know how long it takes to reach a value of $8,000. Okay, I'm going to go ahead and put the 8,000 on the right-hand side. But, so basically they're giving us the y. They're giving us the answer. So this is what's different from the problems we were doing yesterday. This time, the thing that we're looking for is an exponent. And we're going to need logarithms. As soon as you see that it's an exponent is what you're looking for, ultimately you're going to need a logarithm for that. Okay? But it's not time for that yet. Just like we saw on the problems, the first 3 problems we did in the last video, what's our first step going to be?
Divide by 250.
We got to divide by 250 to get this whole thing by itself. So that's your first step, to divide by that 250. Okay, so I'll divide by 250 on both sides. Wait, why did I make that line so long? Okay. So now that gives me 1 plus 0.07 over 4 to the 4t power equals. What is 8,000 divided by 250? 32. So I get 32. All right, is everyone with me so far? All right, what is it time to do now?
Add that. Inside.
Not add, okay? What would let me show you in a simpler, right, okay? This whole thing with the 1 plus 0.07 over 4, that's just a number, okay? Like if I had 11 to the 4t power is equal to 32, I think you would all know that it would be time to write this in log form, okay? And in log form, it would be like log base 11 of 32, whoops, is equal to 4t. So it doesn't matter that instead of 11, I have this ugly expression. I still have to rewrite this in log form now. So be very careful. It's cumbersome, but you can do it. Okay, so just be very careful. If I need to rewrite this in log form, obviously I'm going to write log. Now, what is the base for this ugly expression?
1 plus 0.07 divided by 4.
Exactly. The base is this entire parentheses, okay? The base is 1 plus 0.07 over 4. That whole thing is the base. And then what comes next?
32.
Then comes the 32, right? Because these like switch sides. And then equals 4t. So we've gotten one step closer towards getting t by itself. It's over here on the right-hand side. I need to do one more thing to get t by itself. What is that? I need to divide by that 4. Okay, so I'm going to divide by 4 on both sides. All right, so I've solved the problem now. It's just a matter of how we type this into the calculator. That's all we have to do now. All right, go ahead and give it a try. I'm going to pause the video. All right, so let me show you guys how to type this into your calculator. First of all, we have to use the change of base formula. So I'm focusing on, let me highlight it for you. Right now I'm just doing this blue part. All right, well now I've colored it yellow. So by the change of base formula, if I want to put this in my calculator, I need to do log of 32 divided by log of the other expression. So that's what I'm going to do first. So in my calculator, I'm going to go log 32. Okay? You know what? Actually, let's do this. Go into fraction mode first. What's the denominator of this entire problem?
4.
4 is the denominator of the entire problem. If I were you, it's going to be safest for you just to type in that 4 first. Get that out of the way. Okay? Now, in the numerator, it's where I need to do my change of base formula with the log 32 over log 1 plus 0.07 over 4. So up in the numerator, now I hit my fraction button again. So now I can do my change of base formula up here. So up here, I will go log 32. Whoops. Hold on. Close my parentheses. Over log 1 plus, and of course I'll need another fraction in there for the 0.07 over 4 part. And that's it. That's how you type it into your calculator. Boom. So everyone should have gotten this. And rounded to 2 decimal places, that's 49.94. And that's what I want. So do not round it all the way to 50. Okay, so everyone who was unable to type that in your calculator before, you're going to have another opportunity in a minute. And I want to see every board up.
Did you learn anything new right
Any questions on number, whatever that was? Number 4? Okay, take a look at number 5. All right, so now on number 5, like we said a minute ago, as soon as I see compounded continuously, I know I'm going to use the PERT formula, okay? So just hold that in the back of your mind. How long does it take? By the way, as soon as I see how long, I know I'm going to be finding t. I know I'm going to need logarithms because that's an exponent. So just in my mind, I know, this is going to be a logarithm problem. So here I go. How long does it take for an investment to triple? So listen to this very carefully because this is a little strange for your brains to understand. I didn't give you the initial amount. I just said how long does it take to triple. So here's a little trick that you can use. Make up a number. It doesn't matter what the initial amount is. It'll take the same amount of time for any amount of money to triple. Okay? So just give me a simple amount of money, Malik.
Like
Just make up.
$14.50.
I said simple.
Oh, $14.
Okay, say.
14.
let's just do $100. I just want a nice round number that you can do mental math. Okay. $100. Let's say $100 was the initial amount. So if you're sort of spacing out, you're gonna look up a minute from now, and you're gonna go, wait a minute, where did 100 come from? That wasn't in the original problem. So again, guys, I'm just making up that number because it doesn't matter. Okay? You can make up when it says how long does it take for something to triple or double. It doesn't matter. Okay? That's when you can make it up.
Okay.
All right? So so if the initial amount is $100, so I just made that up. I'm using the PERT formula, so that's the P in PERT. So here comes the E, and then now is the rate. So I see that 13%, so what am I about to put? Just 0.13, okay? Because if you move the decimal twice, it lands right in front of the 1. And then the T is what we're looking for, how long. So I will just go ahead and put the T. Now, if we want the investment to triple, if we started with $100, how much will we have once it triples?
300.
We will have 300. Okay? So now we can go on and solve the problem. So what will be our first step? Divide by 100. And see, this is the point at which you see that it didn't matter what numbers we picked. Because no matter what number you picked, once you divide, your answer is going to be the same at that point. Because what do I get when I do this 300 divided by 100? I'm going to get 3. And no matter what numbers you picked, you would get 3 right now. Okay? What is the time to do now, guys?
Natural log.
Right, it's time to go to log form, and it will wind up being natural log, yes. So for a moment, though, I'm just going to blindly write this in log form. So if I went blind, it would be log base E, and then the, whoops, my E went away. Log base E, and then the 3 comes over here, and the 0.13t is over there. But you're right, we don't write log base E. We write natural log, so natural log 3. So what's the last step?
Divide by 0.13.
Correct. So we will divide by 0.13 on both sides. All right, so that's going to give us t equals, and then just put this in your calculator. Okay, so to 2 decimal places, that's 8.45. And this is years. Okay, any questions about number 5? All right, let's go ahead and do one more problem on this video. Problem number 6. Okay, so we have a car at the initial value is $18,990. First, let's write the model. So this is just basic exponential growth. So we're talking about the model that's just the amount, 1 plus the rate to the power of time. That's just your basic exponential growth. It's not compound interest or anything. Oh, decreasing. Skirt! Nick is going, not plus, Mr. Burton. It's definitely minus. Thank you, Nick. Yeah. Decreasing problem is going to be 1 minus the rate to the power of time. Okay? So hold that in your mind. Let's see. With this rate of 11%, I'm thinking 0.11. So ultimately, I'm going to do 1 minus that. And that's what's going to go in my parentheses. So what is 1 minus 0.11? That's 0.89. So when I write my model, and they told me what variable to use, so I'm going to go v equals, and here comes the initial amount. And then instead of putting 1 minus 0.11, please go ahead and put 0.89, and then to the power of t. And for a model, definitely leave t as a variable. So now we will use the model to estimate the value after 8 years. So that's like what we did yesterday, okay? They're giving us the time. So if we do that, it'll just be, the value will be at $18,990 times 0.89 to the 8th power. So you just put that in your calculator and you get what you get. Can somebody read me the answer to 2 decimal places? Anybody do it yet? Am I too fast?
7,475.58.
All right, like that?
Yep.
Okay, so that would be the value after an 8-year period. Any questions on that? So that's what we did yesterday. Stay with me, Tim, buddy. Now, use it to find when. All right, as soon as you see that word when, you know we're finding t. That's an exponent. We're going to need logarithms, so brace yourself for that. When will the value of the car be half of its original value? What is half of its original value?
9,495.
Yeah, if we just take this number and divide by 2, that will give us half of its original value. So setting up the model, so I've got this 18,990, 0.89 to the power of time. If I want it to be half of its original value, I'm just dividing this by 2. Read me that number again.
9,495.
Okay, so I got this number simply by dividing the original number by 2, half of its original value.
Oh, so that's
Okay. All right, did I lose anyone just then? All right. So, what's my next step?
Divide both sides by 18.
Exactly. Divide both sides by 18,990. Okay, so those are going to cancel out. And you should not need a calculator at this point to know what the answer to this is going to be. Because it's got to be half of its original value. So this better give you 1/2. Okay, otherwise you set it up wrong in the first place. But yeah, this does in fact give you 1/2, of course. Of course it does. So once you get to this, what's my next move? Not divide. It's not going to be any algebra 1 step. What do I need to do? Log form, okay? Because we got a base and a power. Only way to get it at this exponent is to rewrite this in log form. So I'm going to write log. What comes next? Base 0.89. What comes next? 1/2. And then equals t, all right? Because these two sort of switch sides when you do this. All right, and most of us will have to use a change of base formula to put this in our calculator. So we will have to go log of 1/2 over log of 0.89. Okay, so just put that in your calculator and that'll be it. Yeah, I just started the video. We'll talk about it later. So looking at number 7, we have 2 different situations we need to sort of compare. You place $400 into an account that's earning this much interest rate. How long will it take for the amount to reach $1,000? And we're going to do it for compounded monthly versus compounded continuously. So let's see. As far as the formulas go, both of these are compound interest. But if you have, if you're compounding monthly or daily or quarterly or something like that, that lets you know to use this formula. On the other hand, if it says compounded continuously, that lets you know to use the PERT formula. Okay? So that's step one, is knowing which formula to use, because I'm not going to tell you. So you have to know that on your own. Okay? So now that we know which formula to use, let's substitute in all the numbers that we have. So we know the initial amount. We know P. So that's going to be 400. All right, so that's my P. So I'm doing 1 plus, we know the rate. Okay, 4.1, so what am I going to put? 0.041. Okay, so I'm going to have 0.041 over, okay, over 12 because of monthly, and then 12 and T. Okay, now what am I going to set that equal to? 1,000, because it said how long till it reaches 1,000. So that's the amount that we're going to have, like, eventually. So that's the setup of the equation that you need to solve. Any questions on that setup? At the same time, let's go ahead and set up the other one. So the PERT one. The principal is still 400, the initial amount. But instead of that ugly parentheses, I can just put E and then RT. So here comes that rate for R, 0.041. And then again, just T, because that's what we're being asked to find, is how long. And again, that's going to equal 1,000, the eventual amount. So we need to solve both of these for T. So for both problems, the first step is going to be the same. Malik, what's the first step in both cases? Divide by 400. We got to divide by 400 in both cases. So let's do that. So I'm going to divide by 400 on both sides in both problems. Okay, what's 1,000 divided by 400? 2.5 sounds too small.
5 over 2.
Is it really 2.5?
Yeah.
All right. Then, okay. I'm messing up all different kinds of ways. Okay, so 0.41, 12. Okay, so 2.5. Okay, if this had been, you're never allowed to round. If this had come out to be like 1.3 repeating or something, then I would have to just leave it as a fraction. Okay, so watch out for that. So over here, I'm going to have e to the 0.41t is equal to 2.5. Or you could just leave it as 5 over 2. Okay, now over here on the left, what is it time to do now? Log. Okay, I know it's cumbersome, but that's what it is. This parentheses, that's the base. So I'm going to have log base 1 plus 0.041 over 12. That's the base. And then comes the 2.5, and then equals 12t. All right, on the other side, if I rewrite this in log form, it would be log base e 2.5 is equal to 0.41 t. And you're right, instead of writing log base e, we will put natural log.
Mr. Bird, isn't it supposed to be
0.041. Okay, so this will be natural log 2.5 is equal to 0.041 t. Okay? On the left side, what's my last step?
T by itself.
How do I get this t by itself?
Divide by 12.
I need to divide by 12 on both sides. Okay? And on the right-hand side, how do I get t by itself?
Divide.
Okay, so I'm going to divide by that 0.041. All right, so it's just a matter of putting all this in the calculator to get our final answers. Okay, so here we go. All right, so as I go to put this in my calculator, I would recommend start in fraction mode. What's the denominator of this whole situation? 12. So if I were you, I would put the 12 in first. Okay, now in the numerator, I'm going to have to do the change of base formula. So I need to do log 2.5 over log parentheses. So I need to make another fraction up here. So I will do my log 2.5 over log 1 plus, and I'll need another fraction, okay, so there's your 22.39. So round it to the nearest 2 decimal places. I should see 22.39 on everybody's paper. Okay, the natural log version is a lot simpler. Natural log 2.5. Okay, hold on, let me just move this over. Okay, so we'll just have natural log 2.5 over 0.041. All right, and that's 22.35 if we round up.